Bismillahirrahmanirrahim. Lecture number 5. The most important topic of electrostatic, that is Coulomb's law. So, first of all, statement. What Coulomb's law states? This law states that the force of attraction or repulsion between 2 point charges is directly proportional to the product of charges and inversely proportional to the square of the separation between these 2 point charges. Now, first of all, what is point charge? That's a very important point. So, point charge is such a charge which has no internal structure. What is meant by internal structure? Internal structure means that there is no other particles or constituent particles inside this charge. Like in biology, we study unicellular organism, amoeba, chlamydomonas, which are unicellular organisms, but they have internal structure: nucleus, protoplasm, etc. But here there is no such other materials inside the point charges. That is the actual exact definition of the point charge, having no internal structure. But here we can also define point charge in relative terminology. That is, point charges are those charges whose separation is very large as compared to the magnitude of the charges. Means the charges magnitude are very small, but they are very far away from each other. At that time, these two charges are called point charges. Now, we will explain this statement. Let's suppose we have 2 point charges, that is Q1 and Q2. Here both the charges, I consider both the charges positive. You also consider both the charges negative, or one charge positive and another charge negative, because in definition we say that attraction or repulsion. So if the charges are same, force will be repulsive. If the charges are opposite, means plus and minus, at that time the force will be attractive. This R is the separation between the centers of the 2 point charges R. Now, the force, which is called electrostatic force or Coulomb force, depends upon the product of magnitude of the charges. Means if the magnitude of both the charges are very large, the force of attraction or repulsion will be also very large, because it is directly proportional to the product of magnitude of the charges. But if this R is constant, but if we kept constant the magnitude of the charges but increasing separation between them like this, at that time the force will be decreased, because by increasing separation, field interaction of these 2 point charges will be decreased. So the force of attraction or repulsion will be decreased. So therefore, force of attraction or repulsion is directly proportional to the product of charges and inversely proportional to the square of distance between their centers or between them. This is first proportionality. This is second proportionality. Combine both the proportionality. So F is directly proportional Q1 multiplied by Q2 divided by R square. Now we will change proportionality sample into equality. So the condition must be applied. We will put equality sample along with some constant. So this is constant word Q1 multiplied by Q2 divided by R square. Here the proportionality constant is represented by K. K is proportionality constant and it is called electrostatic constant. And the value of this electrostatic constant K is 9 into 10 raised to power 9 Newton meter square per coulomb square. But we can replace this K value in other form, which is called permittivity of the free space. So equation number 4 can also be written as F is equal to 1 over 4 pi epsilon naught Q1 Q2 by R square, equation number 5. What is epsilon naught? Epsilon naught is called permittivity of free space. Free space means that force of attraction or repulsion between these two charges when there is no material medium between the charges. Either there is free space, vacuum, or air. So at that time the Coulomb force can be calculated as. But if there is a medium between these two charges and the medium must be always insulator, so the force will be decreased. It is just like a common example when two bodies are in contact, or when two persons quarreling with each other, they both hit each other and there is no third one to separate them. At that time the damage will be more. But if a third person enter and separate both of them, at that time the damage will be minimized. So therefore when we put insulating material, the force will be decreased. If you have any problem, please upload your question